Alright, so yesterday, boys and girls, we started speaking about factorizing a quadratic cubic polynomial. And that was something brand spanking new. We haven't done that before. This is quite a new thing to us. So I ask you to please go and have a look at number 2.5, 2.6, and 2.10. So 2.5 and 6 I already did on the board. So 2.5 said 4x to the power of 3. Someone by the door, yes. So it's 4x to the power of 3 minus 7x squared minus 7x plus 10. That was given to me. So I said, the only thing in the book that I have a little bit of a thing against is, they should probably have called this thing like fx or gx to the process to make it easier. I'm going to do fx here. It just makes it easier. So step number 1 was either you cheat or you do the right thing. We stay in South Africa, so you cheat. That's what we do. No, I'm just joking. Alright, but that is what South Africans do. But okay, any case. So, ladies and gentlemen, if you don't have the silver calculator, what we do is the factor theorem. What did the factor theorem say again for last time? If I substitute the value and I get naught, that thing I substitute is the factor. In plain English, it can be divided. Okay, so what I did beforehand is I took my silver calculator to just get a little bit of time on my side, and I looked at what could possibly be answers. And one of the answers that I got on my calculator was 1. But then I need to show them how I substituted. So I took 1 and I put it in everywhere. And then your answer will be 0. You're going to go and test that. Which means what to me? That 1 that I substituted is part of the factor that can be divided into this. So what do we need to remember? If that is plus 1, the factor is going to be x minus 1. If that is minus 1, the factor will be x plus 1. So I said, therefore, x minus 1 is a factor. Herman, hierdie lyk soos is Grieks, né? Okay, goed, so jy's alright. Right. So, what happens next is, that would be x minus 1 in brackets, 4x squared. So where did I get the 4x from? If I go to the top, I say to myself, alright, with what should I multiply that x to get to that? And the answer would be 4x squared. And then I said, with what should I multiply that negative 1 to get to that positive 10? And the answer is minus 10. So I already did my bx. Remember bx, the thing in the middle, I already did that. So I erased it. I'm just going to show you what I did. So here on the side, I went and I said, alright, that is bx. So I said bx times x, and that times that. That gives me the minus 4x squared plus bx equals, where do I get that minus 7x squared from? Right there at the top, I say that's the value that I'm looking for. And then from there, remember I make the x's fall away and I get b as negative 3, which is this value that I have here now. And that thing, which I have there now, is a straightforward quadratic expression, which I can factorize, hopefully, can factorize in grade 12. I did my factors here, 4 times 2 is 8. 5, if you subtract that, you get the 3 that you're looking for. There's my brackets, and then I factorize it. Remember, signs are going to be different. Biggest will be minus. So how did I get this? That gives me 5. That gives me 8. Hence, therefore, minus at the back, plus at the front. Yes, Chantal?
So what will happen if you don't factorize that?
What will happen? You don't get marks. Okay, all right. I understand what you're asking me, because that's going to happen in the next one. Yes. Like I laughed myself. All right, so what she's trying to say is, if it's not possible to factorize that thing, so the question says factorize fully. And if you can't factorize this, then you stop. Then it's fully factorized. I know what she's going to ask me. What about the formula? Remember, we're not solving x, we're factorizing. That formula is for solving x. It's not for factorizing x. Okay. Dis nie om te factoriseer nie. Okay, so that was my answer. Ladies and gentlemen, just the same thing over and over. So if you just get used to the pattern, what happens, I think the most difficult thing, the most difficult out of all is just to get the B. That's the most difficult. The rest are factor theorem. I mean, substitute if you have a calculator, which most of you does. It helps a lot. All right, let's look at number 2.6. So number 2.6, I said yesterday, this was a fight that we had in grade 9. And I had a theorem that I always said because I knew where we were going towards. And my theorem said, I don't know who of you was in my grade 9 class many moons back, but I always said, if there is a negative, the negative is always a common factor. Always. Why? Because if I factorize, I don't want to factorize with a negative. If I take it further, I don't want to factorize with a negative there. If you think about quadratic, for example. So yeah. Except for that, the other thing that makes life a little bit more difficult for me here is this. And I remember mentioning this in grade 9 as well, but it wasn't a big thing, and I mentioned in grade 10 as well again, that if you have a fraction, that fraction is part of your common factor. So what I did to make life easier for myself is, I said the following. I took out a half an x from each. So if I take out, and remember it's not a half an x, it's minus a half. Where do I get the x from? It's minus a half that I took out. So that would make that minus a positive, which is actually what I want. So 1 divided by a half is 2. That becomes minus 3. That becomes minus 12. And that becomes plus 4. And this thing, this thing is easier to factorize, especially when you think about going further, than working with that thing. I mean, now you've got, but it's not impossible. It's not impossible to leave the half, just take out the negative, but yeah. Okay, so what I did next was, I needed to do my factor theorem. Now you can do the factor theorem on the top, doesn't matter which one you use, but get 0. Once again, I cheated a little bit. So if you cheat a little bit, I'm just going to show you. Look at what the calculator tells me. So what I'm going to type in, I'm going to type in this yellow one. Okay? Or the top one doesn't really matter. So let's do the top one rather. So I'm going to have minus 1. And then I'm going to have positive 3 over 2. 3 over 2. And when you do this, don't go, what the hell? Way back, old school. Old calculators. I don't know if you remember those. Before the natural display. Mine did that for a fraction. So don't go, what? That's just another way of writing fraction on a computer, on a calculator. You see there it makes it 1.5. Then I've got 6 and I've got negative 2. So if I say equal, look at the weird answers that I get now. But that's the one that I'm looking for. You see there the negative 2? And that would have been done if you didn't have a calculator, you've done that in substitution. 1, negative 1, 2, negative 2. Okay, correct. So, what I then did was this. I then said, if I then take the equation and I put my negative 2's in, I then know my answer must be 0 because it's one of the factors. Ta-da! Yes?
Is dit vir as jy nou
verder gaan?
In met 'n
Correct.
Dis vir verder gaan. Dis
Maar jy kon dit gebruik. Sê vir my, jy gaan dieselfde antwoord kry. As jy minus 2 daarin staan, gaan jy ook kry. So dit maak nie nou 'n saakie, maar ek het daai nodig eintlik vir my volgende stap. So ek het sommer net al reeds gedoen. Okay. So that means that x plus 2 is a factor. Remember opposite sign. Okay, fantastic. And then I went into and I said, all right, that means the following. So I have the answer. Let's just run through this where I get it from. So that's what I just told Ms. Fitzgerald. Look there, there's mine. Let me just write it out neatly. So I want to factorize. That was the idea. That was the opdracht. Nee. So I'm going to start off by saying, therefore, minus a half. Because taking out minus a half was part of factorizing, wasn't it? It was a common factor. And then what will I also have? I'll also have that x plus 2, which I just proved is going to be a factor due to the factor theorem. And now I do the process like I always do it. So now I ask myself, with what should I multiply? Now be careful now. I'm going to use this one because the half is already out there, the minus half. So with what should I multiply the x to get to that? The answer will be 2x squared. Okay, with what should I multiply the plus 2 to get to that plus 4? And the answer must be positive 2. And then remember, in the middle, we just close this thing off. In the middle, there's going to be bx. What do I do now? I multiply those two and I multiply those two. So I'm going to get 4x squared plus bx squared is equal to, now you go to your thing at the top, minus 3x squared. And that means 4 plus b equals negative 3, which means b is minus 7. So I just go back here. I erase that. And here is exactly what Shantae said is going to happen. This thing won't be able to factorize further. You can try anything. How do I know that? If I go back to my calculator, do you remember the 3 answers that I got? So the 3 answers I got was that. Immediately because of the decimal. How on earth do you factorize decimals? You're not able to do that. The next one is also a decimal. The only one that is a perfect answer is negative 2, which is the one we already have. So that means to me that that thing cannot be factorized. Yes, it can be solved. I can use the formula to solve it, but that's not what they're asking me. So this is then fully factorized. You can't go further. Right, questions? Make a note about that half and the negative. It's a nice question. It's not difficult, but that's the type of thing that catches you out in the test. Lekker. Smaak daai koffie nou. Right. Last one. 2.10. 2.10, I also gave it for a reason. And the reason why I gave it was that there's stuff missing. Or to the naked eye, it may seem that stuff is missing. What's missing? There's no x there. Does that make that thing a non-cubic expression? No, it's still cubic because it's 3 there. If you really have an urge to have the x there, you can actually go and rewrite this thing by doing this and just say 0x plus 1. But I mean, that's just silly. But just to indicate there is a c value. The c value is 0. Especially if you think of working with a calculator. So, ladies and gentlemen, I need to factorize. So, first of all, factor theorem. But ladies and gentlemen, we have this stuff with us. Use it. If you don't have it, then this one says this. My answer, it's my wife. She's sick around. Yes. Jy vergeet. So ek sien die moeilikheid nie. Die kinders sit en loer my nou. Dis is wat hy al gaan aan. Ek dink is nood. Maar baie geluk met vrou. Ek is lief vir jou. Dankie. Ek gaan vir jou vanmiddag 'n verrassing besorg. Lief vir jou, hoor, lekker is. So both of us from that she's like, congratulations, I got money. She's like, I'm waiting at this. Oh, jy het ook vergeet, nou toch. Dit gebeur as 'n mens ouer word. Alright, so ladies and gentlemen, I'm going to use my calculator and I'm going to see what would be the easiest one. It just saves time. There's nothing wrong with it. Even though it's a little bit of cheating, but sometimes a little bit of a cheat here and there just helps you along pretty nicely. So that's going to be 0, and then that would be 1. That gives me a third. Now, if you're going to substitute a third for me, I know you're lying, you used your calculator. I mean, really. Next one is a half. Minus 1. So what I'm going to do is, I'm going to go here, I'm going to say the f of minus 1. So it's minus 6 minus 1 cubed, and then minus 1 squared, and that would be plus 1, and that's 0. So what is my deduction? Therefore, x plus 1 is a factor. Fantastic. Okay. So now I go and I say, therefore, yes. Zeg weer. Ja. Vol punte. Okay, want ek gaan dit nou doen. Because, ladies and gentlemen, it doesn't really matter where you do it, but I'm going to show you now. I'm going to keep to what I have here. You're going to do it at the end somewhere. So what she's implying is she took out the negative there, which is the right thing to do. You're going to see now where you could have done it there, you could do it later. So what's going to happen now is, if I do what I do this as the same the whole time, I'm going to go and ask, what should I multiply x with to get that? Any of the two doesn't really matter, I have to get that. And the answer will be negative 6x squared. And then I'm going to say, with what should I multiply the 1 to get to the positive 1? And the answer will be positive 1. And then I'm going to do my bx over here. So I'm going to multiply that, and I'm going to multiply that. So I'm going to get minus 6x squared. Yes, and I'm going to get plus bx squared is equal to what? Is equal to that, which is negative 7x squared. And that means minus 6 plus b is minus 7. So b is negative 1. So into my formula here, I can now go and substitute minus x. But for me to factorize it further, it won't be possible with that negative in front of the 6. So if you took it out at the beginning, you don't have a problem now. So my first step would now be get rid of that negative. So I'm going to take a negative out, and it's going to become 6x squared plus x minus 1. And now I go and I say, right, I need factors of 1 and 1, 6 and 1, 1 and 6, 2 and 3, 3 and 2. That's all the same way around at the end there. So it's 2 and 3. To subtract to get 1, here's my answer. And it's going to say the following. It's going to say, let me just quickly write down what I have already. I'm going to have that. Then I'm going to have 3x and a 1. I'm going to have 2x and a 1. Signs will be different. Biggest is a plus and a minus. If I'm not mistaken, the answers was a third, negative a half, and negative 1 was the answers, which they used to quite have there. Alright, ladies and gentlemen, hopefully by now you understand how to factorize the things. Now we're just going to do 2 or 3 to show you how to solve for x. So you can write today's date, which is the 23rd. So it's 2306, and then you can just say solving cubic functions. Solving cubic functions. Okay, so now we're going to do exactly the same thing. The only difference is now it's not an expression anymore, but now it becomes an equation. So, I'm going to give you this. I'm going to ask you, me. Okay, yeah. So look at this. I'm going to have example number 1. 2x to the power of 3 plus 9x squared minus 17x plus 6, and that's equal to 0. So what's the difference now from the previous round? The difference is in this, that now I have a equal to something. It's not always going to be 0. But the equal makes it an equation, which means I'm now going to get x answers. So if you now look at the calculator, let's type that in on the calculator. That is the stuff we're going to look for now. We're going to look for the physical, what is x. But it works exactly the same way. At the end of you factorize, you just need to tell me what x is. Okay, so let me quickly show you. Let's do this one on the calculator. So it's 2 and 9 and minus 17. So it's going to say 2, 9, minus 17, and 6. It tells me that x is negative 6. That's the answers. So how nice would it have not been to just write down the answers? But this thing will count 5 to 6 marks. And just writing down the answer will earn you 1 probably. The next one is 1. The next one is 0.5. So They expect me to do it without a calculator, so I'm going to do 1 for factor theorem. So I'm going to start off. Very important to write this down before you start. Must be in standard form. And standard form is that what you see on the calculator. A to the power of 3 bx squared cx plus d. That is standard form. If it's not in standard form, you cannot start the process of factorization. Okay? So if it didn't look like that, you would rewrite it so it looks like this. So you get your standard form going, and then equal to 0. You can write that there as well. And from there, I can then factorize. Okay, fantastic. So we said, by making use of the calculator, we said that 1 will be an x answer, a factor. So I'm going to substitute 1. So I'm going to get 2. Now here you can't really say fx because it's an equation, not an expression. So now you just substitute. So I'm going to have 1, 3 plus 9, 1 squared, 17, 1, and 6. And now you can't say equal to 0 there. You just use the expression part to do the factor theorem. Now I would go and say that is equal to x, 0, which indicates to me that x minus 1 is a factor. That's it, the factor theorem. Fantastic. Now I go into my next step of the process, and the next step of the process said x minus 1 bracket with what? Should I multiply that x to get to that? The answer will be 2x squared. With what should I multiply the negative 1 to get to positive 6? And the answer is negative 6. Now, here is where I'm going to catch you out. Remember, we're solving an equation. You have to write this here. Otherwise, you won't be able to solve it. The only place where you don't do it is over here with the factor theorem. I mean, there we're using the expression section, just seeing what can divide into. We're not solving anything there. But there was an equal to 0, so here the equal to 0 needs to be entered as well. So in here, I'm going to do my bx, and you don't have to go and write bx, ladies and gentlemen. I like doing it in pencil. If you are comfortable doing it, it's fine. So then I go and I say, all right, those 2 and those 2. So I'm going to get negative 2x squared, bx squared, equal to, if I go to the top, 9x squared. Okay, so minus 2 plus b equals 9, so b is 11. So into my equation here, I'm just going to go and say plus 11x. Alright, now you've got choices. You either factorize or now you can use the formula, correct? The formula that says x equals minus b plus minus the root of b squared. You may use that because that is a formula we use to solve quadratic equations. So let's just first see if we can't do it without it. So 2 and 1, 1 and 2. On this side I've got 6 and 1, 3 and 2. To add, to subtract to get 11. Here's your answer. 6 times 2 is 12, 1 times 1 is 1. So I'm going to get this. X minus 1, then it's an x and a 6, a 2x and a 1. Everything equal to 0. Don't forget that. Right, signs will be different. Biggest one is a plus, most definitely here, most definitely there. So now, and this is where the difference now comes in. Normally we would have stopped there because it's factorized. But now they ask the x answers or the solutions. So I'm going to end off by saying therefore x is 1 or negative 6 or positive a half. And there's your 3 answers. Exactly what the calculator told me, if I'm not mistaken. And that's the only difference, boys and girls. It's the only single difference between factorizing and getting the x answer. Okay, so let me give you one. where you need to use the formula. So all of you quickly try this one for me. It says the following. It says, example number 2. It says x to the power of 3 plus x squared minus 11x minus 3 is 0. Okay, so the question said, please solve for x. Please solve for it. You saw the process, we did quite a few now. So see if you can quickly solve x for me there. And I'm already telling you, you're going to use the formula to get to the x answer. So I said x minus 3 is a factor due to the factor theorem. And then I said, all right, And there I showed it, I worked it out on my calculator. And you would have seen when you did it on calculator, you'd see you get decimal answers. That's already a dead giveaway. And then I said x times what gives me that is x squared. And I said minus 3 gives me plus 1. And then I worked out b to be 4. And already I see problems here. Because factors of 1 and of 1 to add to get 4 is impossible. So this thing would not be able to factorize. So if they asked me, factorize it, you would have stopped here. But now the question said, solve for x. Now the only x we know at this stage is that one. That's 3. But what do we do here? Now you use the formula. So I'm going to go into my formula. X equals negative b plus minus the root of b squared minus 4ac. Everything over 2a. So negative b would be minus 4 plus minus 4 squared minus 4 times 1 times 1 over 2 times 1. And then I grab my calculator and I say, alright, let's move it across. So let's just get to the right mode here. So it's minus 4, minus 4 plus the root of 16 minus 4. That becomes 16, that is 4. At the bottom, I'm going to have 2. So my first answer says negative 2 root 3. So what I'm going to have here is, therefore, x is 3. That we know. Or, then I'm going to have this answer, which is minus 2 root 3. Or, and then I go back, and on my calculator, I'm just going to go backspace and make that a negative. Minus 2 minus the root of 3. And depending on what they ask you, you may leave the answers in the form that you feel comfortable with. Sometimes they say leave it in simplest third form, or they say anything. Sometimes they say you have to round it off, but round it off will also be fine. So if you told me this, and then you would probably tell me minus 0.27 for that one, and for this one it would be minus 3.73, minus 3,73. So that would also be acceptable. I've got a quick question here. We'll think back a little bit now. So, you remember when we did the parabola? A parabola always had how many x answers? 2. But sometimes it happened that the 2 we got was exactly the same. Am I correct? So sometimes when we solved a quadratic equation, you probably get to something like, let's say you get to something like this. X minus 3 is 0. How many x answers does that thing have? So theoretically, it's got 2. Correct? There's one, and there's the other one. Practically spoken, how many are there? Actually just 1. What's the answer? The answer is 3. What did that mean to me in terms of a parabola? What did that mean to me in terms of the parabola? It said something about the parabola. There was a little thing there. Ek sien jou hand is vinnig op. Sê my eers. Sê?
Yeah, I think it's when you want the parabola to be a function or something, when it's in the inverse, you just draw it out. It's not that.
Okay, so let's just quickly chat about the parabola. That is a parabola, correct? When I solve x, what am I getting? I'm getting these things over here. Am I correct? So if it happens that my answers are the same, how the freaking hell would the parabola look like? Full marks. If it happens that you get the same answers, all that it means to me is that all that it means to me is that parabola's turning point is also the intercept. That's what it means. And if I get no solution over there, what does it mean then? So let's say you get an answer, you can't factorize, you can't get it, it becomes imaginary. What happens there?
So then it doesn't cross the x-axis.
Absolutely. Then this thing doesn't cross the x-axis. All right. So exactly the same thing now, because remember, when we look at the cubic function, we're going to draw pictures of that. Now in Afrikaans, ek sê altyd vir die kinders, julle gaan sien as ons daar kom. A cubic function, to me, is almost like two parabolas welded together. The weld is actually that little flame thing you have to put the goggles on, otherwise you get arc eyes. They say it's so. I can't do it. But when you put two metal things together and bind them, like with glue, I call a cubic function two parabolas glued together. Because a cubic function normally looks something like that. So what I see is, I'm going to get there hopefully sometime this week. You see there, it's like two parabolas, and there's a point where they like get together. That point is a name, it's called the point of inflection. Want hierdie ding verander sy konkaviteit. Ooh, is groot woorde nou. But all that I'm trying to get to is, what have we been doing the whole time now? We've been factorizing and now we've been solving x. What are the stuff we're getting? We're getting this. 1, 2, 3. That's why there's always 3. But do you agree with me that this could possibly happen? Am I correct when I say this? Could that happen? It is, I think, possible. How many x answers you get now? You still get 3, but 2 of them are going to be the same. Am I correct? Why? Because it's also a turning point. So don't go, when I get the same answers, there's a meaning behind it. Do you think this is possible? No, it won't be. I thought to myself I'm going to do both, but it's not possible. You have to. Alright, so you get the idea, ladies and gentlemen. So what you're going to do for me for tomorrow, now you're not going to do it now, we see each other for a second, then I'm going to go on. But what I would like you to do on page 139, exercise 5. I'm not going to spend, I told you I was not going to spend a tremendous amount of time on this. This is not to me the most important section, it's just a means to get to where we want to. So at exercise 5, forget what they say at the top. All you do for me is just solve for x. Now for tomorrow, do for me number 6, and let's make it number 10, and let's make it number 7. Just those 3 for tomorrow, just solve for x. Alright, so that is then the end of this chapter. Okay, fantastic. So you can draw a line. Now we're moving into differential calculus, which is also question paper 1. Still the same books. I'm just going to close this up here. And I'm going to start a new one for us for differential calculus. So, ladies and gentlemen, at the beginning, I'm going to give you a lot of theory, a lot of things that I'm going to say, notes that you need to make, interesting facts, so that we build a little bit of a background in terms of what differential calculus is. Now, while this thing opens up, differential calculus, those of you who are thinking of taking engineering, who are thinking of going into a mathematical direction in university, are thinking of stuff like your sciences and so forth, where there is maths, welcome to university. Differential calculus and what we do here, no, if you study for a doctor, you won't do that. I see all the smiles. Ladies and gentlemen, differential calculus, what we do. Now, always say, I don't understand it because to me the internet is pretty big. But they say the internet that most normal people know are the tip of the iceberg. The real internet is that backdoor internet, which we don't know much of. It's even more bigger. The dark web, it's even bigger than what we know. So differential calculus to me is almost in terms of differential calculus and what we need to know. So why does this thing not allow me to quickly just do this? Alright, so if I look at differential calculus, what we do is that. Alright? That is what we do in terms of differential calculus. We're just going to look at what is the basics and how does the basics work? So, what is differential calculus and why do we use it? And for what do we use it? So, I like this book. I once went to a session that was held by this Basson guy, Jay Basson. He is a maths lecturer at, I think it was UJ at that stage. And they have a very interesting paragraph as they start off there. It's a lot of things, but it said, I'm going to read one or two things. They say differential calculus, they say it's one of the most unbelievable things in terms of human mind, in terms of mathematics. They said it was founded, very interesting, they said it was founded, it's said here by a guy called Newton, well, any case. But what they say here is differential calculus, and you'd see that when we start doing it. It's maths that is all to do with movement, change, stuff going up, stuff going down, that type of thing. So why do we do differential calculus? There's about 4 reasons why we do it. Reason number 1 is, if you remember correctly from grade 11, and I'm back at my parabola again. So you don't have to write down anything, you can just listen for now. So I'm back at my parabola. So in grade 11, the thing we need to understand about a parabola, a hyperbolic function, an exponential function, is that it's called a curve. A curve means what? It's ever changing. It's never the same. In contrary to that, if I look at a straight line, it's constant, isn't it? It's always the same. So if you think in terms of this thing, remember we had the gradient, which was always the same. If we think of a parabola, the gradient is never the same. I mean, if I had to ask you, what would be the gradient there? Then you must probably do that and you get a gradient. If I ask you what is the gradient there, you're going to get another one. And there you're going to get another one. And so I can go on. So in grade 11, just before we sanitized, we spoke about getting the average gradient between 2 points. Now we're going to do differential calculus and you will be able to find the gradient at a specific point. The next reason is engineering. In terms of maxima minima. The next reason is tempo of flow, drawing the graph, and that's about it. That's about what we are going to focus on this year. Alright, so you can pack away, we'll go on the next period.